All right, assalamu alaikum everyone. Let's begin. So we were doing integration, and today is going to be the last session that we spend on this. And in this session, we are going to be doing some practice questions. Okay, so that's going to be the focus in today's session. I'm going to start with you. You are going to let me know, first of all, if you have any questions. We will start from those questions, and then I'll do a couple of others from the worksheet as well. So let's start with your questions. First of all, you should let me know if you have any problems, either from the worksheet or from any of the recent papers. Okay, so this is what you can actually use to decide which method you should be using to integrate a function. Okay, now there are three primary cases that you could have, three main categories of functions you could have. One is that you have a simple function. Simple function means there's no product or fraction involved. It's just a simple function like this: sine of something, sine of 2x plus 1, maybe you have secant square of 3x minus 2. If you have a simple function like this, simple function means there is no product or fraction involved. In that case, you just use direct formulas, the ones that you're given in the formula sheet. They are the ones that you use in that case. All right. Now, if it's a product, for a product, there are only two possibilities that you have for integrating a product. So if you have two functions, two expressions being multiplied, one possibility is that you use substitution, and the other is that you use integration by parts. Now, in your syllabus, you will only have to use substitution if it is given in the question. So if it is substitution, they will tell you in the question that you have to use substitution here. All right. And if they don't tell you that you have to use substitution, then there's only one method for integrating products, and that is integration by parts. So that's pretty straightforward as well, in the sense that you don't have to think much when deciding how to integrate a product, because if it is substitution, they will tell you that you have to use a substitution. If they don't tell you to use a substitution, then the only other method that you have is integration by parts. Okay, so integrating products is also pretty straightforward in that sense that you don't have to think which method to apply. Of course, integration by parts itself sometimes turns out to be a relatively complicated process, but deciding what method to use here will not be a problem. The problem is mostly going to be when you're deciding how to integrate fractions, because for fractions, you have a number of different methods. Now, first of all, if it is a substitution, they will tell you that you have to use a substitution. So again, for that, you don't have to think much. It will always be given in the question if you have to use a substitution. If a substitution is not given, how do you think about integrating fractions? You think of the log rule. You think of whether you have something like this in the fraction, that the derivative of the denominator is in the numerator, or you can multiply or divide by a constant to make it a form like this. Then you apply the log rule and it converts to this thing. All right. If the log rule doesn't work, if it's not something that you can convert to a form like this, then the next thing that you think about is, can the tan inverse rule work? For that, you need a form that looks like this: constant in the numerator. So in the numerator, you need to have a constant. And in the denominator, you need to have something in this form: x squared plus a squared. So one x squared term and one constant. Okay. In the denominator, you need an x squared term and a constant term. And between them, you need to have a plus sign. If you don't have a plus sign, you can't integrate using tan inverse. If it's a minus, you'll have to do something else, maybe partial fractions, but tan inverse will not work here. For tan inverse, you need x squared term and a constant. You can't have an x term as well, only x squared and constant. And they should be adding together like this. They should be added together like this. And in the numerator, you need to have a constant like this. That can be converted to tan inverse. Now, if it is something that cannot even be converted to tan inverse, what's the next thing that you could think about? Partial fractions. Can you break down the denominator in partial fractions? You think about that. So you think of whether you have some factors in the denominator, you could break them down using partial fractions. Okay. And then after you're done with partial fractions, those individual fractions that you get, you could apply either the log rule or the tan inverse rule. The earlier two rules that we did, you could apply any one of them after finding partial fractions. Okay. Now, sometimes even partial fraction doesn't work. So let's say it's not the log form, it's not the tan inverse form, and you don't even have factors in the denominator. For example, if you have something like this, x plus 1 over 2x. Now, it doesn't follow any of these three forms that we did earlier. In this case, what you can do is you can break the numerator. Break the numerator into two parts. So write x over 2x separately and 1 over 2x separately. And then you just integrate those two fractions separately one by one. Okay, so this is simple integration. This could be converted to log, and you get a result from that. Okay, so that's another idea, that you break the numerator down. If that also doesn't work, sometimes what happens is you have an improper fraction. If you have an improper fraction in which the degree of the numerator is greater than or equal to the degree of the denominator, then what you can do is you can use this rule from polynomials, dividend over divisor, that can be converted to quotient plus remainder over divisor. Okay, that's the next rule that you have. You could use something like this. If it's an improper fraction, you use this identity, and once you have used this identity, you integrate these two one by one separately. Okay, and then the final option is, if none of those methods works, you just convert that to a product instead. For example, if you have ln x over square root of x, now none of those earlier methods is going to work here. You can't even break it down. You can't do partial fractions. Numerator also has only one term, so you can't break it down. In this case, what you can do is you can just make it a product instead. And now you could try integrating it by parts if you want. Okay. So these are different methods that you have to know about for integrating functions. All right. So this is one way you could think about it. Most of the thinking is going to be required when you have to integrate fractions. The rest is not going to be that complicated in terms of choosing the right method. Okay. So that's about it. Now let's start with a few questions. So let's start with the one that Arib asked about, question number 30 from the worksheet. Let's start with that. P3 integration. This is the worksheet that's uploaded there. And you have questions assigned from this as well. Let's try this. This is question number 30 from the worksheet. Let's see how we can do this. All right, so the diagram shows the curve y equals 5 sine cube x into cos square x for x between 0 and pi over 2. And its maximum point M is there as well. This is the turning point. Now in the first part, it says, find the x coordinate of M. Now M is the turning point, right? M is the maximum point. How do you find maximum point or a turning point of a curve? You put the derivative equal to 0. So the first part is actually related to differentiation. Let me write that function down here. We have y equals 5 into sine cube x into cos square x. That's what the function is. We are looking for the x coordinate of the turning point, so we have to find the derivative of this and put that equal to 0. Let's differentiate it. dy over dx. Now it's a product, right? Sine cube x into cos square x. Now let's actually write it in a proper form first of all. So sine cube x, what exactly does that mean? Sine cube x means it's actually sine of x whole cube. All right. Sine cube x is just a short way of writing sine of x whole cube. And then you have cos of x whole squared. This is what the actual function is. Now it's a product. You have two expressions multiplying and you have 5 outside multiplying as well. 5 is just a constant. You could just keep that outside. That will remain as it is. And now this is a product. You have one expression here. This is, let's say, u. You have another expression here. Let's call this v. Now, in order to differentiate it, you have to use the product rule. How does that work? That's uv dash plus vu dash. All right. Let's apply that. U remains as it is, first of all. So that's sine of x whole cube, that remains as it is, into derivative of v, derivative of cos x whole squared. Now, how do we integrate cos x whole squared or cos square x? We start from the outermost function. The outer function here is the power function. All right, so you have to use the power rule here. How is that going to work? You multiply by the power, so 2 gets multiplied. Then you keep whatever is inside as it is, and you subtract 1 from the power. The power is 2 right now, it becomes 1. And then you multiply by the derivative of the part that is inside the power. So the base that you have, what's the derivative of cos x? The derivative of cos x is minus sine x. You multiply by that. All right, plus. That was just uv dash. Now you have to do vu dash. Now v remains as it is, which is cos of x whole squared into u dash. That means derivative of u. Again, the outer function here is the power function. It's sine x whole cube. So you apply the power rule here. 3 gets multiplied. And then you have sine of x whole squared because you subtract 1 from the power. The power 3 becomes 2. And then you multiply by the derivative of the base that you have. What's the derivative of sine? The derivative of sine is cos. So you have cos of x multiplying here. This is what the derivative is. All right. Now, since we are looking for the turning point, what we can do is we can just put this equal to 0 at the turning point. At the maximum point, the derivative would be equal to 0. So we put this whole thing 0. On the other side, you have 5 into let's simplify this whole thing. 5 into minus 2. Minus is coming from here. Then you have this 2. Then sine x whole cube and sine x here. That is going to become sine raised to power 4x into cos x plus you have cos square x here and another cos x here. You have 3 here. So this becomes plus 3 into sine square x into cos cube x. That is what the derivative turns out to be. Okay. Now we need to solve this equation. What do we do for this? 5 goes to the other side, gets divided by 0 gets divided by 5. So 5 gets eliminated. What are we left with? We have this equation minus 2 into sine raised to power 4x into cos x plus 3 into sine square x into cos cube x. And now we need to think about how to solve this equation. Remember, we are just looking for the x coordinate of m. Solving this equation is going to give us the x coordinate. Now, how can we solve this equation? That's the problem, right? Now, what we can do is we can take something common from this, right? We have sine raised to power 4 here. We have sine square here. What we can do is we can say, let's take sine square common. All right. So sine square is common between both of these terms. And then cos is also common. So you can also take cos of x common outside. And then what are we left with inside the brackets? We have minus 2 sine square x from this first term. And from the second term, we just have 3 cos square x. And this whole thing equals 0. All right. Now, what do we get from this? We have a product, sine square x into cos x into this equals 0. We have three expressions being multiplied, and the result is equal to 0. That means either the first one is equal to 0, so either sine square x equals 0, or cos x equals 0, or the third one, which is minus 2 sine square x plus 3 cos square x, that equals 0. We get three equations from that. Now we need to think about the interval for x that we have here. X is between 0 to 0 and pi over 2. So we are looking for a value that is in the first quadrant only. You can see it's 0 to pi over 2. Pi over 2 is 90 degrees. So we are only looking for a value in the first quadrant. Okay, so we don't have to go outside the first quadrant. Okay, now the first equation is going to give us sine x equal to 0. Now, where is sine x equal to 0? It's not something that we can use quadrants for because the basic angle here is 0. What we do is we think of the graph of sine. Where is sine 0? Sine is 0 when x is equal to 0. That's one possible value. Then the next value will be pi, that is outside the interval. So from this, we are only getting one value of x, which is x equal to 0. Okay, so that's one possible value. Now let's look at the second one. Cos of x equals 0. When is cos 0? It's 0 at pi over 2. Right? Think of the graph. It looks like this. The graph of cos. So it's 0 at pi over 2 and then 3 pi over 2. So only pi over 2 is in our interval. The value of x that we get from this is pi over 2. These are two values of x that we're getting. Now we need to solve this third equation. How do we solve this third equation? We have sine square and we have cos square. We can convert that to one single function. Let's say we write it as minus 2 sine square x plus 3 into 1 minus sine square x, that equals 0. Now simplify this. This gives us minus 2 sine square x plus 3 minus 3 sine squared x equals 0. Now simplify this. This gives us minus 5 sine square x plus 3 equals 0. We could take that to the other side, or let's keep it here for now. And that gives us 5 sine square x equals 3. Sine square x equals 3 over 5. Now we have to take square root of this. Square root of 3 over 5. Let's see what that turns out to be. Can somebody tell me what square root of 3 over 5 is? I can't find my calculator or answer. What's square root of 3 over 5? .775, is that exact? We want at least 4 significant figures in our working. Do we have a more accurate value than this? 0.775. Let's see if I can find the calculator somewhere. 0.77459. Okay, good. Let's write that down. So when we take square root, remember we have to put plus minus. So that's 0.77459. That's the value that we're getting. Okay. But now remember, we are only in the first quadrant. All right. So we're only going to consider the positive value of sine here for that reason. Why? Because in the first quadrant, sine is positive. Just find sine inverse of this and see what value of x you get from that. Okay. Sine inverse of this, you'll get a value in the first quadrant. You don't have to find the basic angle and all that because we know that the angle is in the first quadrant. You can just find that directly by using sine inverse. What do we get from this when we do sine inverse of this? 0.8861. Okay, thank you. So the value of x that we have here is 0.8861. These are three values of x that we're getting. X equals 0, x equals pi over 2, and x equals 0.8861. Now, look at the graph. Point M is what we're looking for. Now, it's very clear from the graph that the x coordinate of M cannot be 0 because 0 is right here. It cannot be pi over 2 is here. So it's not 0 or pi over 2. It's somewhere between them. So the value that we have here is this one. This is the value of x that we were looking for. This is not M. It's some other value. This is also not M. It's also some other value. Okay. So the coordinates of M therefore are, the x coordinate of M therefore is 0.8861. That is what we were looking for in the first part. Okay, now let's look at the second part. In the second part, it says using the substitution u equals cos of x, find by integration the area of the shaded region bounded by the curve and the x-axis. Now remember the formula from paper 1. You have to memorize this formula. It's not given in the formula sheet. Area between a curve and the x-axis, it looks like this. Integral of y with respect to x, and you have limits of x here. Okay, so x equals a to x equals b. That's the area formula that you have. Integral of y with respect to x. Now, let me write down that function here. The function that we have is y equal to 5 sine cube x into cos square x. That's what the function is. Okay. Now, we need to find the area of the shaded region. So we have to integrate it. Area is given by integral of y with respect to x. Right, that's what the formula is. So what's y here? Y is 5 sine cube x into cos square x with respect to x. We need to integrate this with respect to x with limits from 0 to pi over 2. These are the limits that we have, 0 to pi over 2. Let's write those limits here, 0 to pi over 2. So essentially what we have to do here is we just have to evaluate this integral. Now for evaluating this integral, they've given us a substitution. All right, so when they give us a substitution, we have to use that. So it says using this substitution, u equals cos x, find that area. Now let's write the substitution down here. U equals cos of x. This is what you'll be using here. All right. Now, remember when you have to use a substitution, we also find the derivative of that because we need to replace dx as well. For that, we need the derivative of this thing. So one thing is we have u equals cos x. We'll put that there. But before that, let's find the derivative of this as well. Du over dx. What does that turn out to be? The derivative of cos x is minus sine x. Now you have to make dx the subject. And that gives you dx equal to minus du over sine of x. This is what we get from here. All right. Now we just input these values. Instead of, in place of u, we input cos x. And in place of dx, we input this whole thing. Don't forget the limits, however. The limits are also going to change. So if you want to use your integral in terms of u, the limits here are also going to change. So let's actually evaluate those limits right now as well, so we don't forget it later. The lower limit that we have is x equal to 0. And the upper limit that we have is x equal to pi over 2. What about the corresponding values for u? U equals cos of 0. Cos of 0 is 1. So the lower limit turns out to be 1. And u equals cos of pi over 2. Cos of pi over 2 is 0. So now you see the lower limit is turning out to be 1 and the upper limit is turning out to be 0. Okay, don't just switch it randomly. If you want to switch it, you'll have to put a negative sign there. Otherwise, you can just keep them like this as well, and that will give you the correct result. We'll see how that works. Okay, so we have done all that we need to do with the substitution. Now let's just input these things in that integral and see what happens. So instead of cos, you input u. All right. So what is this going to become? What we can do is we can actually write this 5 outside the integral, because constant that's being multiplied with the whole integral. It doesn't matter if you write that inside or outside. You can write that outside. And then the integral is sine cube x. Let's keep it as it is for now. We'll see what to do with this later. What about cos square x? This converts to u squared. Okay. Cos square becomes u square. And what about dx? Dx can be replaced with this whole thing, which is minus du over sine x. Now let's simplify this. Sine x is going to get cancelled with one power here. And what we're left with is 5 into integral of, we have this negative sign here, remember? So that's minus sine square x into u square with respect to u. Okay, so we're done with the first step. We have replaced cos x with u, and we replaced dx with this whole thing. So that's something that we're done with. Now we need to make sure that all expressions that we have in this integral are in terms of u. The problem here is we also have an x here. We have sine square x, and that's a problem. Okay, we need to convert this to something in terms of u as well. How do you do that? We could convert sine square to cos square, and then we could use the substitution. So we could write sine square as, so let me actually write this minus sign outside the integral as well. It's just a constant. We could write that outside. Inside, instead of sine square, I could write 1 minus cos square x. And now we can do that substitution. In place of cos x, I could input u, so it becomes 1 minus u square whole multiplied by u square with respect to u. This is what the integral turns out to be. Now we have everything in terms of u. We can integrate this. Remember, the lower limit is 1 and the upper limit is 0 here. Okay. How do we integrate this now? It's a product, but don't jump to integration by parts right away. It's much simpler than that. If we just multiply this thing with this, that's going to make it very simple. 1 into u square, that's just u square. U square into u square, that is u raised to power 4. This is what we need to integrate with respect to u with limits 1 to 0. Now let's integrate these expressions one by one. What's the integral of u square? With respect to u, it's a power function, right? U raised to power a constant. We can use the power rule here. It becomes u cube over 3. Remember, for using the power rule, the condition is this thing has to be linear. In integration, the condition is this thing has to be linear. So it is linear. We can use the power rule directly like this. It becomes u cube over 3. And what's the integral of u raised to power 4? It's u raised to power 5 over 5. And that is what your integration is. Now just input the limits from 1 to 0. And that gives you minus 5 into input 0 first of all. That gives you 0 over 3 minus 0 over 3. So that just becomes 0. Subtract from this the case when you input 1. And that is going to give you 1 over 3 minus 1 over 5. Simplify this and see what you get. You have minus 5 into minus 1 over 3 plus 1 over 5. We just evaluate this and see what this turns out to be. Okay, 1 over 5 minus 1 over 3. That gives me minus 2 over 15, then multiplied by minus 5. And that is 2 over 3. So the value of this area that we end up getting from this is 2 over 3. All right, so the diagram shows a sketch of the curve y equals x raised to power 1 over 2 into ln x and its minimum point m. So you have this point m here. The curve cuts the x-axis at the point 1, 0. You can see that point here, 1, 0. We need to find the exact value of the x coordinate of m first of all in the first part. Now that's relatively straightforward. It's differentiation. M is the turning point, right? How do you find turning points? You differentiate and put the derivative equal to 0. Let's do this very quickly. We have y equals x raised to power 1 over 2 into ln x. How do we differentiate this? It becomes dy over dx equal to, it's a product, right? How do you differentiate products? You have to use the product rule. Let's say this is u and this is v. The derivative would be u v dash plus vu dash. All right, let's just apply that. What's the derivative? So let's have to keep u as it is first of all. So it's x power 1 over 2 as it is. What's the derivative of ln x? It's 1 over x plus derivative of x power 1 over 2 into v as it is. So ln x as it is into derivative of x power 1 over 2. That's going to be 1 over 2 multiplied by the power. It's a power function. Multiply by power. Subtract 1 from the power. So that's minus 1 over 2. All right, that's the derivative. Now, since we're looking for the turning point, you put this equal to 0. And that gives you x raised to power minus 1 over 2, x power 1 over 2, and then this 1 in the denominator, that gives you x power minus 1 over 2, plus 1 over 2 into x power minus 1 over 2 into ln of x. Now we need to solve this equation. What we can do is we can first multiply the whole equation by 2 to get rid of the fraction. That gives us 2x raised to power minus 1 over 2 plus x power minus 1 over 2 into ln x. So I've just multiplied the whole equation by 2, and that gives me this. How do we solve this equation now? We could take x raised to power minus 1 over 2 common, and that gives us 2 plus ln x inside. From this we get x raised to power minus 1 over 2 equal to 0. That's one possibility. Or we get 2 plus ln x equal to 0. It's a product. That means either the first should be equal to 0 or the second should be equal to 0. Now, x raised to power minus 1 over 2 equal to 0. What do we get from this? This is just going to give you x equal to 0. Now, it's pretty clear from the graph there. The x coordinate of m is not, in fact, it's not actually going to give you this. It's not going to give you anything actually. So that's actually wrong, because if you write it as 1 over x power 1 over 2, that equals 0. And if you just multiply this there, it does not give you any solution. So this is not possible. So the first one actually does not give you any solution. All right, so you don't get anything from this. If you were to solve the second one, that gives you ln x equals minus 2. How do you solve this equation? The base of ln is e, remember? That is going to go to the other side and become the base of minus 2. All right, so you have x equal to e raised to power minus 2. That should be the x coordinate of that point m. We were looking for the exact value for that x coordinate. This is what the exact value is, e raised to power minus 2. Okay, that was the first part. Let's look at the next part. You could leave it like this, and that's okay. Or if you want, you could also write it this way, 1 over e square, and that's also going to be okay. All right, let's look at the next part now. Now it says use integration by parts. So they've told you what method you should be using to find the area of the shaded region enclosed by the curve, the x-axis, and the line x equals 4. This is the shaded region that we are looking for. Now, even if it looks like a triangle, do not assume that it is one. It's not a straight line. Even if it looks like it, it's not a straight line. It's part of a curve. So we can't make it a triangle. Can't think of it as a triangle, okay? So we're looking for this shaded region. It's the region between the curve and the x-axis. Limits are going to be from 1 to 4. Limits are from 1 to 4. All right. Now, let's write this down here. The area that we're looking for, let's write down the function here. First of all, the function is y equals x raised to power 1 over 2 into ln of x. Area between the curve and the x-axis, what is that going to be? We apply the limits from 1 to 4 on this function, and that is going to give us the area. All right, this is what we need to evaluate essentially, because this is what the area formula is between a curve and the x-axis, integral of y with respect to x. Okay, now how do you integrate this? It's a product, and they've also told you that you should be using integration by parts for this. Now, let me actually copy the formula for you. The way it's written in the formula sheet, this is how the formula looks like. Okay, so we'll keep the formula sheet in front. This is the formula that we have to use here. Okay, the first thing that we need to decide here is what do we take as u and what do we take as dv over dx? We use I-late for this. Which two functions do we have here? We have an algebraic function, that's here, and the other function is a log function, and that is here. Whatever comes on the left side, remember, that is u. Whatever comes on the right side, that is dv over dx. So algebraic function, which is x power 1 over 2, that is going to be taken as dv over dx here. And the log function is going to be taken as u here. We can write that down on the side. U equals ln x and dv over dx equals x raised to power 1 over 2. All right. Now, what do we need to evaluate to be able to use this formula? We need du over dx and v. So we differentiate u to get du over dx. What does that give us? Derivative of ln x is 1 over x. We integrate dv over dx to give us v. What's the integral of this thing? It's a simple power function, a linear expression raised to power something. All we have to do is add 1 to the power, so it becomes x raised to power 3 over 2, divide by that increased power, so divide by 3 over 2. And that gives us 2x raised to power 3 over 2 divided by 3. This is what v is. And now all we have to do is input values in that formula and see what we get from that. So I'm inputting values on the right side here. U into v. What's u? U is ln x into v. V is this thing. 2x raised to power 3 over 2 divided by 3. Subtract from this integral of v, which is again 2x raised to power 3 over 2 divided by 3 into du over dx, which is 1 over x. And we need to integrate this thing. Now, the first part turns out to be 2x raised to power 3 over 2 over 3. And with that, we have ln x. Now, this is an integration that we have to do. We can write the constant outside, 2 over 3. That's just multiplying. We could write that outside to make things simpler. Inside the integral, what do we have? X power 3 over 2, and then minus 1 from the denominator. That becomes x raised to power 1 over 2. We just need to integrate this thing with respect to x. Okay, let's integrate it. And that gives us minus 2 over 3 into x raised to power 1 over 2 plus 1, which is 3 over 2, divide by that increased power. So you divide by 3 over 2 here. Let's simplify this. And we are going to get 2 over 3 into x raised to power 3 over 2 into ln x. This 2 goes to the numerator, gets multiplied with this 2, and that becomes 4. 3 into 3 in the denominator, that is going to become 9. So we have 4 over 9 into x raised to power 3 over 2. This is your integral. All right, so we're done with the integration. Now we have to input those limits. Limits are from 1 to 4. Let's just input those values and see what we get from that. 1 to 4, just input these limits. Let's input 4 first of all, so it becomes 2 over 3 into 4 raised to power 3 over 2 into ln, sorry, 4 raised to power, yeah, that's okay, into ln of 4 minus 4 over 9 into 4 raised to power 3 over 2. Subtract from this the case when we input 1 there, and that is going to give us 2 over 3 into 1 raised to power 3 over 2 into ln of 1 minus 4 over 9 into 1 raised to power 3 over 2. This step is necessary for you to show. You can't skip this step. You have to input values and show to the examiner what values we're inputting. You have to show the step. Okay. Now, do we need an exact value or? Okay, so we need to give our answer to 2 decimal places. Now, after this point, it's okay if you would just want to put this whole thing on your calculator directly, and that's going to be acceptable. If it was supposed to be an exact value, in that case, you would have to show the steps. But in this case, you can just evaluate it directly from your calculator and see what that gives you. Now, if I were to do it on my calculator, 2 divided by 3 into 2 raised to power 3, which is 8 ln 4 minus 4 divided by 9 into 8 minus, in fact, plus 4 divided by 9. And that is giving me 4.2825. That's just, so if you were to write this to 2 decimal places. So in this case, it says in the question that you have to write your answer to 2 decimal places. You have to make sure that you follow that instruction as it is. 2 decimal places would be 4.28, and that's your final answer. Okay, 55. All right, so this is what we need to integrate here. It says by first using the substitution u equals e power x, we need to show that this integral equals ln of 8 over 5. Now it's a 10-mark question, so that means it is going to require quite some working. Let's start with this. So it says you have to use the substitution. Let me write that down on the side here. U equals e raised to power x. Remember, when you have to use a substitution, we also have to find the derivative of that so that we can replace dx with du as well. Du over dx, what's that? That is just e raised to power x. If you were to make dx the subject here, that would give you du over e raised to power x. So you have to input u equals this and dx equal to this. When doing the substitution. Okay. Now let's do the substitution. But before that, we need to slightly change it so that we could replace e raised to power x with u, because right now we have e raised to power 2x, we have e raised to power 2x here, we have e raised to power x here. We could write e raised to power 2x as e raised to power x whole squared, right? Just using indices rules. For example, if you have 3 raised to power 2x, for instance, you could write it as 3 raised to power 2 whole raised to power x, right? Or you could also write it as 3 raised to power x whole raised to power 2, right? Using indices rules, you can do that. So that's exactly what we're doing here. Instead of e raised to power 2x, we could write this as e power x whole square. Why are we doing this? Because we want to replace this thing e raised to power x with u. In the denominator, we have e raised to power 2x as well. So we could write this as e raised to power x whole squared. And then we have 3 e raised to power x plus 2 dx. We need to evaluate this and show that this turns out to be ln of 8 over 5. Now let's do that substitution. Instead of instead of e raised to power x, let's input u. So we have u squared in the numerator. In the denominator, we have u squared plus 3u plus 2. Instead of dx, we put this thing, which is du over e raised to power x. Okay, now we still have e raised to power x here. We know e raised to power x is just u. We could write this as u as well. So it becomes u square over u square plus 3u plus 2. And we get du over u here. One of these u's is going to get cancelled. This gets cancelled with this. And we get integral of u over u square plus 3u plus 2 du. This is the integration that we have to do. Let's look at the limits. Lower limit and the upper limit. Let's see what they are. Lower limit and the upper limit. The lower limit here is 0 for x. When we convert it to u, it becomes e raised to power 0, which is just 1. The upper limit is x equals ln 4. When we convert it to u, it becomes e raised to power ln of 4. Evaluate this on your calculator. You will realize this turns out to be just 4, because e and ln, they are actually inverse functions of each other. They cancel each other's effect, and you're going to end up with u equals 4 from that. So these are the limits. The limits are supposed to be from 1 to 4 here. Okay. Now we need to integrate this. This is the integral that we have. Now it's a fraction. What rule can we apply here? We think of the rules that we have for integrating fractions. Does the log rule work? Let's think about that first of all. For the log rule, for the ln rule, we need the denominator. We need the numerator to be the derivative of the denominator. What's the derivative of the denominator here? The derivative of the denominator is 2u plus 3. Well, we could get 2u by multiplying here by 2 here and dividing by 2 outside, but we can't have plus 3. So we can't really convert it to this form. That's not possible. Okay, that's one thing. Log rule doesn't work. Tan inverse, for tan inverse, you need a constant in the numerator. You don't have a constant in the denominator as well. You have this u term, so it's not that form as well. Partial fractions, well, we could think of that. If we can factorize this somehow, then we could use partial fractions. Can we factorize this? If you think about it, we can actually break the middle term. The middle term can be broken here like this. It becomes u over u square plus 2u plus u plus 2. And then you could factorize this so that it becomes u into u plus 2 plus 1 into u plus 2, which is going to give you u plus 2 and u plus 1. So you could factorize it like this. Okay. And once you factorize this, you find the partial fractions after this. So you say u over u plus 2 into u plus 1. Find the partial fraction for this first of all. And then we could just integrate that. So the partial fraction is going to be like this: a over u plus 2 plus b over u plus 1. Multiply this denominator on the other side. That gives you u identical to a into u plus 1 plus b into u plus 2. Now input some values. This can be made 0 by inputting u equal to 1, u equal to -1. You put u equals -1 here. On the left side, you have -1. On the right, you have 0 plus b into -1 plus 2. And that gives you b equal to -1. How can you make the other bracket 0? This becomes u equals -2. So you have to input u equal to -2 for that. If you input u equal to -2, that gives you -2 on the left side. On the right, you have a into -2 plus 1 plus 0. And that gives you minus a equal to -2. The value of a turns out to be 2. You have the partial fractions now. So that integral that you had here as a single fraction, that can be written like this. Now we say that integral now becomes, let me actually just copy this here. This integral that we had earlier with limits 1 to 4, this can be written as two separate fractions. One is a over u plus 2, which means 2 over u plus 2, integral of this with respect to u. And the second fraction is -1 over u plus 1. You could have minus outside, and then 1 over u plus 1 du. The limits for both of them are from 1 to 4. Now we can just integrate these two fractions separately. How do we integrate the first one? The log rule works here. The derivative of u plus 2 is 1. So we need 1 in the numerator. We could write 2 outside. It leaves us with 1 over u plus 2 inside. The second one is already the log form. We can integrate that directly because the derivative of the denominator 1 is already in the numerator. So the integral turns out to be 2 ln of u plus 2 minus ln of u plus 1. That's what the integral is. Okay, now just input values. The limits are from 1 to 4. Let's input those limits and see what we get from that. If we input 4, that gives us 2 ln of 4 plus 2 minus ln of 4 plus 1. Subtract from that the case when we input u equal to 1. That gives us 2 ln of 1 plus 2 minus ln of 1 plus 1. Just simplify this. This gives you 2 ln 6 minus ln of 5, and then minus 2 ln 3 plus ln of 2. All right, so this is what we're getting. Now we need to show that this can be written like this, ln of 8 over 5. For that, we need to use multiplication or division laws of logs. But remember, in order to be able to use multiplication and division laws, we need 1 outside the log. We can't have another number instead of 1. So what we can do is, since we have 2 multiplying with ln 6 and ln 3, we can take 2 to the power, so that it becomes ln of 6 squared here. Then we have minus ln 5 minus ln of 3 squared, and then plus ln 2. So we don't have any numbers outside the log anymore. So we have ln 36 minus ln 5 minus ln 9 plus ln 2. Now we just apply that rule of log. Ln of 36, this is, you have a positive number outside, so that comes in the numerator. Minus ln 5, 5 comes in the denominator. Minus ln 9, 9 also comes in the denominator. Then you have plus ln 2, so you have 2 in the numerator like this. Okay, so this is just using multiplication and division laws of logs. Now just simplify this and see what that gives you. 36 over 9 is 4. This gets cancelled. This gives you 4 in the numerator. 4 into 2 is 8. That's ln of 8 over 5. And that's exactly what we were trying to prove here. Ln of 8 over 5, that was a 10-mark question. This is what you would do here. Okay, so again, you have to remember the methods that you have for integrating. Otherwise, in this case, you would not be able to figure out how to integrate it. All right, so you need to have those methods at your fingertips, the methods that we have for integrating fractions. You think of them very quickly. Can the log rule be applied? Can the tan inverse rule be applied? If not, what about partial fractions? What about breaking the numerator? You have to have them in your mind ready, so you should be able to figure them out. which method is going to work. So in this case, we have to factorize the denominator because that can then be converted to partial fractions, and then we integrate it like this. This is question number 37 from the worksheet. Let's just start with this, and then we move on to differential equations, inshallah. All right. Now it says the diagram shows the curve y equals x raised to the power 1 over 2 into ln x. And the shaded region between the curve, the x-axis, and the line x equals e is denoted by r. That is what we're given. Now, in the first part, we have to find the equation of the tangent of the curve at the point where x equals 1, giving our answer in the form y equals mx plus c. So the first part is relatively straightforward. It's just differentiation. We need to find the equation of tangent. That's a straight line. What do we need to find the equation of a tangent? We need two things, a point and the gradient. We already have the point. We know the x coordinate of that point. We can find the y coordinate as well by just inputting that value in the function. Let's do that first of all. So the function is y equals x raised to the power 1 over 2 into ln of x. Now, first of all, let's input x equals 1 in this function to figure out the corresponding y coordinate of that point, because we will need that for the equation of the line, of the equation of the tangent. Let's input x equals 1 for that. When we input x equals 1, we get y equal to 1 raised to the power 1 over 2 into ln of 1. Since ln of 1 is 0, y turns out to be 0, 0. So the point that we have is 1 and 0. Okay, so we need to find the equation of the tangent at this particular point, 1, 0. Now, how do you find the equation of the tangent? We say it's dy over dx. dy over dx, we first have to find dy over dx for that to be able to find the gradient. Then once we have the gradient, we can write down the equation after that. So we first find the derivative. It's a product. It's x raised to the power 1 over 2 into ln of x. We have two things multiplying. So you'll have to use the product rule here. uv is what the original function is. The derivative would be uv dash plus vu dash. Now let's just apply that rule. U as it is, so that's x raised to the power 1 over 2 into derivative of v, derivative of ln x is just 1 over x, plus v as it is, that means ln x, into derivative of x power 1 over 2, which becomes 1 over 2 into x raised to the power minus 1 over 2. Now, if we simplify this, we are getting x raised to the power minus 1 over 2 plus half x raised to the power minus 1 over 2 into ln of x. We input the value of x here, which is 1, and see what the derivative turns out to be. It's 1 raised to the power minus 1 over 2 plus 1 over 2 into 1 raised to the power minus 1 over 2 into ln of 1. Now, ln of 1 is just 0, so the second term becomes 0. We're just left with 1. This is the gradient of the tangent. All right, so this is the gradient of the tangent at that point. Now we have a point and we have the gradient. We can write down the equation of the tangent. That's going to look like this. Y minus y1 equals m into x minus x1. Just input values. Y minus 0 equals 1 into x minus 1. And that just gives us y equals x minus 1. This is the equation of the tangent to the curve at that point. That's the first thing that we were looking for. Y equals x minus 1, the equation of the tangent. Okay, so that's first part, pretty straightforward. Let's look at the second part now. The second part says, Find by integration the volume of the solid obtained when the region R is rotated completely about the x-axis. Give your answer in terms of pi and e. So we need an exact answer. We can't write the value in decimals. Volume obtained. What's the formula for volume of revolution? We are rotating about the x-axis. So it's going to be Vx equals pi into integral of y square with respect to x. That's the formula that we have for finding volume of revolution about x-axis. All right. Now let's look at the diagram. This is the diagram. This region is R here. And the function that we have is y equals x raised to. In the second part, we had to find the volume of revolution about the x-axis. And we wrote the function, squared that. When we find the square of that, this is what we get, x into ln x whole square. This is what we need to integrate now with respect to x. What about the limits? In this case, you can see on the diagram, the upper limit is e. What about the lower limit? This is what the lower limit is going to be. Now, what is this point? How do you find this point? At this point, the value of y is equal to 0. At this point, the value of y is equal to 0. Now, if you see, you already know that y is 0 when x is 1. All right. So you could just do that again if you wanted. 0 equals x power 1 over 2 into ln x. That would give you two values, x equals 0 and x equals 1. But you don't have to, because you already know that the value of y is, this is one point that you have, that's the y-intercept, that's the x-intercept, sorry, 1, 0. So you know that the lower limit here is going to be 1. So this is 1. So what we need to integrate here is the limits that we're going to have here are 1 and e. Let's write that down again. This is what we need to integrate, pi into integral of x into ln x whole squared with limits from 1 to e. All right. Now, how do we integrate this thing? It's a product, and we are not given any substitution here, right? So there's no substitution that's given. When it's a product and we don't have any substitution given, the only method that we have is integration by parts. Okay. So how do we integrate this product? We would have to use integration by parts. Let's write down the formula for that. So this is the formula for integration by parts. Let me have that in front. It's given in the formula sheet. You'll keep this in front. This is what you want to use at this point. Now, how do you decide what to take as u and what to take as dv over dx? Now, let me write that down on the side here. We will be using IL8, right? That is what we want to be using. Whatever comes on the left is u, whatever comes on the right is v. Now, what two functions do we have here? We have x, which is algebraic, and we have ln of x whole squared. This involves logs. Whatever comes to the left is u, whatever comes to the right is v. So we're going to say, let's take u as ln of x whole squared. So u equals ln x whole squared, and dv over dx, sorry, not v, it's dv over dx. dv over dx is ln x whole squared. No, sorry, dv over dx is x. All right. So you've written those two things down here. Now from this, you need to figure out du over dx. So we need to differentiate u and see what we get from that. How do you find the derivative of this? It's ln x whole raised to power 2. remember how we used to differentiate such functions? We start from the outermost function. The outer function is power function here. So we first apply the power rule in this. 2 gets multiplied, ln x remains as it is. The power of ln x becomes 1, and then you multiply by the derivative of what is inside the power. So the base of the power, which is ln x, what's the derivative of ln x? It's 1 over x. So what we get from here is 2 ln x divided by x. All right, that's du over dx. Now what about v? For v, we would need to integrate dv over dx. Its integral is going to be v equal to x square over 2. All right, so increase the power of x by 1 and divide divide by the increased power. That's the value of v that we're getting. Just input these in this formula and see what you get from that. U as it is, this okay, I'm sorry about that. I'm having some internet issues. So we were here, u into v, that's ln x whole squared into x squared over 2. That's u into v. We subtract from this the integral of v, which is x squared over 2, into du over dx, which is 2 ln x over x. And then outside, we have dx. All right. Now let's simplify this and see what we get. We have x squared into ln x whole squared outside divided by 2. And now look at the integral. 2 and 2 get cancelled. X squared, 1 power of x squared gets cancelled with this x. What are we left with? We have x into ln x with respect to x. We need to integrate this thing now. Now it's again a product, but think about it. Is it simpler than before or not? If it's simpler, then you're going in the right direction. Earlier we had x into ln x whole squared. Now we have x into ln x only. So it's simpler than before. So that's okay. We would have to apply integration by parts once more here. Okay. So it's again a product. So we will need to use integration by parts. Again, one function is algebraic, x is algebraic, and the other is logarithmic. So ln is going to be taken as u. You can write that here. U is going to be ln x here, and dv over dx here is going to be x. Now, what about du over dx? That is 1 over x, and v, that's the integral of x, is x squared over 2. Now we need to apply integration by parts in this part again. Let's see what we get from that. X squared into ln x whole squared outside divided by 2. Subtract from this. Now here you apply this formula again. Input values in this function, in this expression. U into v. What's u? U is ln x into v, which is x squared over 2. Subtract from this integral of v, which is x squared over 2 again, into du over dx, which is 1 over x. And we need to integrate this with respect to x. Now, let's simplify this. We have x squared into ln x whole squared divided by 2 minus x square ln x divided by 2 minus integral of just x, right? So in fact, x over 2, we can write this 2 outside if we want. It becomes 1 over 2. Inside, we just have integral of x with respect to x. Okay, now let's simplify this. It gives us x squared into ln x whole squared divided by 2 minus x squared into ln x over 2 minus minus, this becomes plus 1 over 2 outside. What's the integral of x? Integral of x is x squared over 2. And that's your integration. Now you just need to input the limits from 1 to e in this, and that should give you the result. All right, let's do that. What are the limits? Limits are from 1 to e. All right, now let's input e first of all. So it becomes e squared into ln e whole squared divided by 2 minus e squared into ln e divided by 2 plus 1 over 4. 2 into 2, that becomes 4 into e squared. That's what happens when we input e. Subtract from this the case when we input 1, that gives us 1 square into ln 1 whole squared over 2. Now you know ln 1 is going to become 0, so this whole term is going to become 0 anyway. So you can just write 0 for that as well if you want directly. 1 square into ln 1 divided by 2, the same is the case for this one. Then we have 1 over 4 into 1 squared. Now just simplify this and you get the result. This gives us, remember ln e is 1, ln e here is also 1. So we have e square over 2 minus e square over 2 plus 1 over 4 e square. This becomes 0, this becomes 0. We are only left with this last term, which is 1 over 4. So we have minus 1 over 4 there. E square over 2 and e square over 2 get cancelled. What are we left with? We're left with 1 over 4 into e square minus 1 over 4. All right, this is what we get from this. But remember, we are missing one thing, and that's pi. We also had a pi outside. Let's actually write that down here. You could just write it in the very last step as well, as long as you make sure that you remember that. Or you could just write that with all of these terms as well, so you don't forget it at the end. Even if you write it at the end, that's also acceptable. But just to make sure that you don't forget, I would recommend that you write it in every step so that you know there is a pi there. Even if you write it at the last step only, that's also going to be okay. There's no problem with that. Okay, so the final answer therefore turns out to be pi into this whole thing. If you want to write this in simplified form, you would say this is 1 over 4, or maybe take 1 over 4 common as well. It's going to be easier to write. So you have 1 over 4 pi into e square minus 1. That is what the volume turns out to be in this case. All right, that's what we needed to figure out here. The volume of revolution in this case.